In this module, we're going to be creating the actor blueprint for our widget and adding it to our player pawn for use, as well as preparing the blueprints for communication from our user settings widgets. Let's get started. Inside of the UI folder, create a new folder named Actors. Inside of Actors will be all of our blueprints designed specifically for our UI. Create a new actor blueprint named BP_hood and open. Create a widget component and set the widget class to WP_user_hood. Set the size to 1024 by 1024 as that is what it was designed for. Press compile. Drag out a copy into the map. This is designed at 1024 by 1024, but it is also using this value for the size. So the size of this widget is also 1024 centimeters by 1024 centimeters. We need to scale this down. Return to the blueprint and scale the widget to 0.5, 0.5, 0.5. To make handling this easier for us later, let's move this up so it doesn't go below its pivot. Select the widget and move it up to 70. Also, this is our UI in virtual reality. No reason it has to stay a flat plane. Set the geometry mode from plane to cylinder. 180-degree arc angle is a bit too much for me, so I'll set it to 50. Let's quickly create the two events we'll need in this blueprint. In the event graph, create a custom event named change scale. Add a bool input, renaming it to attached to hand, and compile. Drag out a reference of the widget component and create a set relative scale 3D node. From new scale 3D, create a select vector node. Plug attached to hood into pick A. Set A to our 0.5, 0.5, 0.5, and set B to 0.06, 0.06, 0.06. Change the scale of the UI depending on where we are using it. We're going to want the hood to be much smaller if it's attached to our hand, as it will potentially be much closer to our face. Create another custom event named core button pressed. Add an input of type eButtonAction named buttonAction. Add another input of type struct user settings temp and name it temp value. Drag another reference to the widget into the event graph, and from it, create a getUserWidget object. Cast the return value to WP_user_hood. This is never going to change the class, so we can convert this to a pure node confidently. We're going to later create the event we will call here, but for now, let's just remove BP_hood from the map and spawn it from our pawn. Open motion controller pawn darts. Create a custom event named spawnHood. The reason we are doing this here and not in the parent BPP pawn darts is because this logic is specific to this pawn. If you wanted to share this logic with your other pawns, you would create these next events and variables in the parent. From spawnHood, create a spawnActor node. Set the class to BP_hood and connect the world transform of our VR origin to the spawn transform. Promote the return variable to a variable named BP_hood. I'm going to stay organized and keep this in the UI category. From our new BP_hood variable, create a setActorHiddenInGame node and set newHidden to true. Spawn the hood and hide it. This will hide the blueprint until we need it. Pan up to our begin play event and add a pin to the sequence. Call spawnHood there. Let's now set up where the hood will live when it's spawned, as well as the smooth movement in world space logic. Create a new bool variable named userHoodVisible. Create a custom event named smoothly move hood. After we call toggle guardian in our event tick, connect our new user hood visible to a branch, and on true, call smoothly move hood. From smoothly move hood, drag a reference to our BP hood variable and create a set actor transform node. We need to create a reference to where we want our hood to be when it's attached to the camera or when it's attached to our hand. Select our camera component and create a new arrow component named hood arrow. Open the viewport and move it forward to 130 and rotate it 180 degrees to face the camera. Let's move it down a bit as well. About -20 looks good. So I'll type in -20. For when it is attached to the hand, we'll attach directly to the motion controller. Back at our smoothly move hood event, drag out of new transform and create a select transform node. From A, create a t-interp2 node. Get a reference to our BP hood and plug the actor transform into current. Get a reference to our hood arrow and get world transform. So we're going to plug this into current, and from target we'll split, and from our arrow we'll split into the target location and rotation, and we're going to scale this to 0.2, 0.2, 0.2. Right click and create a get world delta seconds node and plug this into delta time. Right click and get a reference to our struct VR player settings variable. Create a break struct node and hide all except UI interpolation speed. Plug that into the interp speed. Duplicate the t-interp2 node and plug it into B on the select transform node. Again, place the actor transform from the hood into current. Bring in a reference to both the right controller and left controller. From right controller, create a select node and set the index to a boolean. From index, create a new variable named hood using right hand. I know this looks backwards, but when we write that hood is using our right hand, that means we are using our right hand to interact with the widget and the left will hold it. From the return value of the select node, get a reference to the motion controller and get its world location. Plug that into the target location. For the target rotation, we want to create a way for the hood to always look at the camera regardless of where it is in world space. Get the actor location from the hood and the world location from the camera. From the actor location of the hood, drag off the vector and search for find look at rotation. Connect the camera's world location into target, and then plug the return value into the t-inter2 node. Set the scale here to 0.1, 0.1, 0.1. Duplicate the above delta time and interp speed nodes and plug them in as well. Back to this select transform node. We're going to set this by the value of our user interface type variable, which will allow this logic to change at any point during gameplay. Get our struct VR player settings and again create a break struct node and only show the eUser interface type variable. Create an equals enum node. Set it to hood and plug into A. Okay, almost ready to test. We need to create the input for opening the hood in project settings. We'll use the small menu button on our left touch controller. Open our project settings and navigate to input and create a new action mapping named toggle hood. The little menu button is accessed in Unreal Engine by Gamepad Special Left. Back in our pawn, search for our toggle hood event. Set user hood visible to the not value of itself, saying if false, be true, and if true, be false. Connect the value to a branch. On true, set the actor transform to the world location of our hood arrow. This is because the hood is not attached to our hand nor our camera. It is only placed there when we need it. So if we walk or teleport anywhere, we want our hood to be next to us as expected. Otherwise, we will see it turn on where we last used it and slowly fly over to us. After set actor location, from BP hood, create a set actor hidden in game. Set the new hidden value to the not of user hood visible boolean. We have already set this bool to the opposite of its current value, so we need to get the opposite again. If we had called this node before setting the actor hidden in game, we would potentially see the snap of the hood to its new transform. When the hood is visible, it will be true. The not to turn that to false, and false will be plugged into new hidden, as in not hidden. So we need to make sure our false of the branch also hide the widget when we're done. Pan up to the teleport logic. The last thing we'll do is set which hand to attach to and which hand to interact with. If we press teleport left, set hood using right hand to false, and if we press teleport right, set it to true. We will generally teleport using our dominant hand, but that's not always the case. We'll change this later. Select the Struct VR player settings and see what the value of e-user interface type is. Mine is set to attached to hand. I'll set my UI interp to 2 so it's nice and smooth but not too slow. If you're noticing that the changes to your struct variable aren't being used, it's because our game instance is overriding them. This only happens at the beginning of the game. Open our game instance darts and change the settings there. So I'm going to change mine to be hood and change UI interpolation speed to 2. Let's finally test this. Spawn the hood. Okay, there's the smooth motion we were looking for. Okay, so now if now it doesn't matter which hand I'm using because it's just attached to the hood. Okay, looking good. I can hide it as well. Awesome. Next, let's set up the communication between our UMGs and blueprints so we can change these settings in game.